Okay, so here we have got um, here I have just written down the statement to create the package. See, this is how you create a package. Here this is the package name, package name, right? Now directory name, the folder that you create inside your Java folder, right? You create the hierarchy of packages in Java folder, JDK Java, your C drive JDK Java. So there the package name of the first folder, the folder created should match this pkg, right? Then here we create a hierarchy of packages. This is how we create a a series of folders. You need to create a folder pkg1. Inside that you need to create a folder pkg2. Then inside that pkg3, like that. In the Java, this pkg1 is in Java folder. So that is how you create a hierarchy of packages. And see, uh, these braces are not there, like package java.awt.image. This Java will be a folder inside which there will be a folder called awt, inside which will be the image folder, and inside this image folder we will be creating our classes. This is a package that comes with the JDK, of course. This is not our custom defined. So, but for understanding purpose, I wanted to show this, that package in Java in AWT, inside that the image has been created. This is the hierarchy created. Alright, so you cannot change the name of the folder, or you cannot change the name of the package. You cannot change these names without changing the name in the folder, the directory where the classes are stored, where the class files are stored, right? So it will throw in an error if package not found. Okay, so you need to ensure that. And here so say we have got a package mypack. Now say for a program to find mypack, right, for a program to find the mypack package, either the program can be executed from a directory immediately above mypack. So say this is a folder mypack. So immediately above the folder the program can reside. That is the Java file can reside, that the dot with the .java extension, that Java file I'm talking about, can reside just in the directory outside my package. Then this program can access the mypack package or any class files inside this package. Alright, so basically you will be able to see in the directory that there is a mypack and that .java residing one beneath the other in your directory. Then this Java file will be able to access the mypack. Okay, and one more method is that class path I talk about in environment variables. There you can create a package, and you can copy the path up till your mypack folder, and you set it there after semicolon. So you can access any class files inside this folder. You can access from other programs, other class file, other Java files that you make. Okay, so the class path environment variable, that there whatever you set the value, after that you append the path to this and you place a semicolon. Okay, to include the path to this so that uh, all the programs, all classes here can be accessed at compile time. Alright, then you can compile with javac, whatever program, whatever file you are and where you will be importing this package. This package you need to import in your file with the import statement. Alright, so here we have got a simple package demo. We have created a package here, mypack, and there is a class here, class balance. There are two data members, string name and double BAL, and class balance is constructor where the values are getting initialized, and one method is there inside this class, void show of return type void, and it is basically printing if the balance is less than 0, then it is displaying the name and the balance, this name and balance. Alright, so when instantiating this class, that is when creating the object, we will be invoking the instructor and passing the values, and those values will get assigned here, and those values we are printing here, right? This is the purpose of this class balance, and we have got another class in this package, two classes in this package. So second class is account balance. Alright, here we have got the main method. Inside the main method we have created we have actually created an array of type balance. This is our custom made data type, which I was saying, this is not a primitive data type, this is a custom made, this is an array, right? You create arrays with a data type, then the name with braces, then new, you allocate memory, I told you, new int. Say if this was an int type array, this is not an int type array, this is a class, our own class type array, this class. So this is perfectly logical. That is how we create our own. Here it becomes our own data type associated with this current this array, and size is 3, that is there will be 3 set of values, 3 rows, basically 1D array, and the indexing starts, as you know, from 0, current 0. These names should match. Current 0 equal to new balance. I'm putting in values here. I am basically the array indexes are pointing to 3 objects created of this class, right? 3 objects, new balance, and we are putting in values here. So basically the constructor is getting invoked here, the values are being passed here, and value is being assigned. 3 sets of values, 3 times objects are created with 3 different sets of values, and they are being referred to by the array indexes, right? Now with a for loop, I get the values displayed. Alright, I pass in the index this from the for loop, current I, right, dot show. So current is referring to the object created, that is the memory allocated particularly to current 0, current 1 respectively, current 2, where there are those rows of data part of that array. First row will have this set of values, second row will have these set of values, third row will have these set of values. So current 0 will be pointing to these in the memory, current 1 will be pointing here. So we are invoking based on that object instance, we are invoking the method show here, and if the balance is less than 0, then only this is displayed. Oh, if balance is less than 0, then only this is displayed. But if balance is not less than 0, then this is anyhow displayed. Right? You can put in an else here also, that if this, else this, but not required. Like balance is not 0 here, so this is overlooked. We come to this statement here, and name and balance are printed. 3 times this show method is invoked, right, and it's printed here. So you save this file as account balance.java file. You can actually yes, you can name it whatever you like, but for easy maintenance we take the name containing the main method. As I told you, you can name the file whatever you like, but the main method containing class should be should be used with the Java command in command prompt when you run the program, like Java class name containing the main method, but Java file name, right? But here here this class is residing in the mypack folder, right, because we put it in our own package here with this statement, and we create a mypack folder also. Since we name it and we save it as with a .java extension, we put it in this mypack folder, then compile the file, that is javac. We compile the file, and then the class file created, dot class file, you take that up. That will also have this name, account balance. So you take that file and you place it in the mypack directory, and because if you create other classes, then it will be able to access from mypack directory. It will be accessing the class file. Then you run the program like this, Java mypack dot. So you compile the program with this javac account balance dot java, or whatever be the name you give, and then when you run the program, you have to run it like this, right? java mypack.accountBalance. Okay, while you are compiling and running the program, in the command prompt you should be just above the mypack directory, that is in the /java. Do not go to mypack, just above the mypack, that is the java folder, right? Okay, so one more thing is here, when running the program containing the main method is residing in account balance here, but since this class is residing in mypack package, we need to mention it here. It is mypack.accountBalance. Simply java account balance won't work. We need to give the mypack, we need to associate it with the package name, since we have created our own package and created the file here. Alright, so this was how you create a package and how you how you compile and execute. Then comes importing a package. So this is how you import this typical prototype of an import statement. So here is an example how you import pack1 dot, say pack1 is the name of the package, dot a may be a class name residing inside pack1, right? And then say you are in class b extends a. Okay, so this is how you import, and this is perfectly you can actually extend a class that you import. I mean, you need to extend, if the class is inside a package, you need to import it before extending, which is, I mean, that class is not in your file, right? Not in the the file that you created. So you need to, that is residing in another file, in another directory. So you put the hierarchy of directories here, dot the class or dot star, that will automatically import all classes. Here is we specifically import this class, and then we will be able to extend this class, right, in our whatever be our file. Say ritu.java, we have created a file ritu.java, inside which there is a class b extends a, right? Okay, so you can also create an object of a class imported. Actually, to create an object of a class imported, to create an object of a class that is not in your class and that is residing in some other package, you need to import the entire package hierarchy and the class, and then you can create object of that class, and you can like process it as the class that is residing in your file. You do whatever you like with it. That is how you import and create a class. Now comes access specifiers. Alright, I'm covering up access specifiers in a separate video. Okay,